Oh, guys, do you know this feeling if you come to a point where you make, I have this point now. Remember in one of my last videos, I asked you, that's the reason why I speak in English again. I asked all the American viewers because the unit that I had a question about, the Sencore LC102, is more familiar over there. So I ask you, hey guys, do you also observe this variation in the numbers that you read, especially for small capacitors? And I cannot find any problem here anymore in the circuits. And is it normal? Yes or no? So I had one response observing similar variance in the readings. And so I made my own thoughts to trace the problem down. I thought, is a problem. In fact, it's not a problem. It's this idiot. I show you. Okay, what we did is we connected our precision capacitance source with 1000 picofarad to the Sencore. I have now a different cable, but that doesn't matter. And we saw, if I hit this value button, that we have this high variance in the readings. Yeah, more or less. Now it's surprisingly astonishing stable, but we had variance at about plus minus 30 picofarads and so on. So what I did is I traced back the circuit. I made measurements. It's a quite tricky techniques behind how they determine the value. They use the current source, which causes a linear rise of the voltage in the to be tested capacitor, and then you have two values where you count pulses in between. Yeah, so voltage values, and it's quite interesting. I made my own notes here. It's like that. Voltage arises. There are 2 points. That is also switchable. They call it low and high trip points. So it's quite a complex thing, and I think I got it roughly now, how all this works. Yeah, processor is counting pulses in between, and using the pulse counting for determining a very precise capacitance value. So, what is the problem? I make it short. I should have done this. That's all. Now, it is rock solid, stable. Look at that. No variance anymore, maybe 1 picofarad or so. I, stupid idiot, forgot to earth or to ground the metal shielding here, the metal case. I expected this to be shielded inside, but it isn't actually. It's floating, as and they especially give the residual capacitance here. So it is actually really a floating device and receiving all the RF interference and hum and all the noise which I have here in the area, collecting and putting into the test leads. And this is what it caused the variance. So everything is fine here. The design is fine. The technical idea behind is fine. It's all fine. The idiot was behind the camera or in front of the camera. I'm really sorry for that, but at least by tracing down the circuitry to find to find a potential error, which there wasn't. It gained me knowledge that I didn't have before. So in the end, it was a good thing for me to learn. But I'm sorry to bother all of you. Yeah, it's just a thing of grounding and shielding. That's all. So, sorry for that. Thank you for participating, nevertheless, in my request, and thank you for the help. I appreciate that. Behind you can see another thing that I'm working on. I'm tracing down a 10 voltage standard. Interesting thing. I have now some readings for about 4 weeks or so, and looks fine. But this is another video. Probably, hopefully, not with such stupid idiots in front of the camera like before. Sorry for that. Nevertheless, thank you. Happy, nice New Year. See you. Bye-bye.